In last lecture, I was discussing about effect of different welding parameters. One, weld quality, especially weld quality means bit shape geometry, then depth of penetration, then deposition rate in details. Today I will start the different welding process. Especially I will discuss in this course the welding process which is related to arc. So here I will discuss especially the welding process, that is arc welding process. So before going to arc welding process in detail, first of all I will discuss oxy-fuel gas welding techniques, because oxy-fuel gas welding techniques also have wide application in industry. That is why first of all I will discuss about oxy-fuel welding technique, then I will discuss about what it is called arc welding techniques. So today's lecture is on oxy-fuel gas welding techniques. Actually, oxy-fuel gas welding techniques is a manual welding process in which the metal surface to be joined are melted progressively by heat from a gas flame. So here generally heat required to melt the workpiece generally coming from a flame, gas flame. So here sometimes filler material is used, sometimes may not require, and here weld piece solidify without the application of pressure to the part being joined. So here application of pressure is also not required. So it is especially a manual fusion welding process. Here general heat supply from gas flame. Here two different gases is used. One is oxygen gas, another one is that fuel gas. This fuel gas can be different types. It can be hydrogen, it can be methane, it can be propane, or it can be proprietary gas also. But the gases that name is acetylene, which have wide application in oxy-fuel welding techniques. So that is why here we will discuss in details about oxy-fuel welding techniques, but we will concentrate more on oxy-acetylene gas welding techniques. So here oxy-acetylene welding is one of the generally popular oxy-fuel gas welding process in which acetylene gas is used as a gas to produce the arc. First of all, we will discuss what is the principle of this welding techniques. Here the principle actually lying in the definition of welding itself. That means here generally heat required for welding is obtained from the flame which is generated due to oxy-fuel mixture combustion. So here the heat which we got for welding, that is generally generated by the combustion of oxy-fuel mixture, and the flame resulting at the tip of the torch, here torch is used to generate the flame. This flame resulting at the tip of the torch is sufficient. Whatever the torch tip flame we are getting, that is sufficient to melt and join the parent material. Here filler material rod is added to molten metal pool to build up the seam slightly for greater strength. Sometimes this filler material is used, sometimes may not use. Here another things in this welding techniques is here generally pressure does not apply. So it is a non-pressure types of welding technique. Now here this is generally, now we will discuss about oxy-fuel welding setup. The simplest and most frequently used oxy-fuel welding system generally consists the following four different component. One is called compressed gas cylinders. Why cylinders? There is generally two different cylinder is there. One cylinder contains oxygen gas, another cylinder contains fuel gas. That is why here it is written gas cylinders. Then gas pressure regulators, as there is two cylinders are there, that is why here two gas pressure regulator are there. And there is hose. Hoses means pipe actually, plastic types of or rubber types of pipe are there, through which generally gas generally supplied to torch from cylinder. And there is a welding torch also. So these are the main component of oxy-fuel welding setup. Here one thing we should keep it in mind, the gas regulator generally attached to each cylinder, whether it is in fuel gas or in oxygen gas cylinder, it generally control the pressure at which gas flow to the welding shaft. So the gas regulators has the main function, we can say. It generally control both flow rate as well as gas pressure required to do the welding operation. Now we will discuss one by one in details. First, so one by one in details in the sense oxy-fuel welding setup details first of all we will discuss. Then we will discuss subsequently its categories, or then its different types of flame, then what are the application, limitation, advantage, safety precaution, everything I will discuss in this lecture about this oxy-fuel welding techniques. So, here this figure represent the oxy-fuel setup. Here generally to what I have already told you, two cylinder is used. One cylinder generally contain oxygen gas. The oxygen cylinder color is black in nature, and another contains fuel gas cylinder. Here maroon types of color is given. We generally different fuel gas cylinder have different color. To see the color itself, we can say what gases is contained by this what is called cylinder. That means inside this cylinder what gases is there, that we can easily guess by seeing the color of the cylinder. This fuel cylinder, whatever the color here it is showing, this color actually the color for this is maroon color, which is the color for acetylene gas, and this is generally two cylinder are there. Here this is a gas torch. Here you see one thing you can see from here, this is a gas torch, this is called gas torch. With this gas torch, this is called hose. Hose means actually hollow pipe actually. Through this is what types of hose? This is generally we can say fuel hose, this is oxygen hose, we can write oxygen hose. So, you see through this fuel gas and oxygen gas coming to this torch, this is called welding torch. Here you can see this is called regulator. In details I will show separately what is the shape of regulator. Here there is two indicator. Here generally this is one indicator, this is another indicator. So, this two indicator, why this two indicator? One indicator represent the cylinder pressure, another indicator shows the working pressure. Working pressure means one is representing what is the pressure inside the cylinder, then another pressure regulate what should be the outlet pressure, that means output pressure of the torch. That means that is called working pressure. Working pressure means the pressure at which welding is done. So, that pressure is called working pressure. So, for a particular types of material, particular types of working pressure is required. A expert welder can easily control that working pressure. So, these two indicator represent two different pressure. Actually, one represent the what is the pressure inside the cylinder and what is the pressure is applying one welding torch. So, that is called working pressure. So, what happens if the pressure generally is within applicable range, then we can do the welding. If the gas reduces, then pressure inside the cylinder also reduces. By this generally what happens, we can use the gases successfully, in the sense we can use the gases as per our requirement. Now, you see here also there is two regulators. Similarly, in oxygen cylinder also there is two regulators. So, this two regulator again, this is also represent, one is representing cylinder pressure, another is represent generally working pressure. How the working pressure is controlled? There this working pressure is controlled by using this fuel regulator, and this is called oxygen regulator. So, by controlling by opening the fuel regulator valve or oxygen regulator valve, we can control the working pressure of welding operation. Now, here another important thing you should remember, at the connection, at the outlet, actually you can say at the outlet of the what it's called, at the outlet of the regulator where the gas is coming out from cylinder to workpiece, that means after regulator once the gas is coming out, then what happens, here used a flashback system, that is generally called flashback arrestor. Here used a flashback arrestor. What is the flashback arrestor? Flashback arrestor, it does not allow backflow of gases. Backflow of gases means what happens? That means it arrests the accident. Actually, what happens if there is a chance of sucking of backflow of the gases, then what happens? There can be chances of bursting, actually chances of accident of cylinder. So, to prevent that burst of cylinder or that backflow of the fuel gases or oxygen gases, generally there is used a flashback arrestor. The function of flashback arrestor, it generally does not allow to return back the gas inside the cylinder. Generally this is the function of that. That means what happens, once there is a chance of backflow of gases, it automatically choke the flow. So, what happens, gas cannot able to enter the cylinder. So what happens, there will not be chance of accident. So this is generally called flashback arrestor. This flashback arrestor used with both fuel gases as well as fuel gases hoses as well as in oxygen gas hoses. So here is on flashback arrestor in oxygen cylinder as well as in fuel gas cylinder also there is a flashback arrestor are there. Now you see, this is called welding torch. Here you can see in this welding torch there is two valve is there. This is called generally inlet valve. Inlet valve. This is called generally inlet valve or not valve. This is generally called inlet valve. VALV actually. VALV. This is called inlet valve of oxygen. That means oxygen inlet valve, and this is generally represent fuel gas inlet valve. By opening this inlet valve, we can control the flow rate, gas flow rate inside this welding torch. Here this actually about this welding torch I will discuss in subsequent slide. Here generally what happens in this welding torch, this portion from this inlet valve to this is called handle. This is generally called handle. Through this handle, this pipe, that means through this gas is separately coming to through separate actually two different pipe to this portion. This portion have a name. This is called mixing chamber. Mixing chamber. That I will show in next slide in details. So what happens in handle region, mixing is not happen. In front of this handle there is a small region where these two separate gases mixing is occur. So after the mixing, generally it's coming out from the nozzle tip, and what happens, once there is used a spark lighter, by a spark lighter we can generate the flame. This flame generally used to do the welding operation. So what happens, how the gas is coming? This gas is coming from cylinder by controlling the working pressure by gas regulator. It's enter to the handle region by inlet valve of oxygen inlet valve and what it's called fuel inlet valve. After that, generally it's come to mixing chamber. In mixing chamber, this two gas mixture is taken place. Once it mixing is taken place, after that by using a spark lighter at the tip of the nozzle, generally what happens, this flame is generated. So here generally this flame then used for doing welding operation. So this is detailed setup and principle of Oxy-Fuel Gas Welding techniques. Now I will show you what is the shape or what is the shape of different nozzle as well as what is the welding torch in detail in the next slide. So here one thing you can see, this is generally the practical view, as you can see that this you can see once you will be in industry, you will be doing oxy-fuel types of welding. There you will see there is generally use a gas torch, which I have already told you. In this gas torch there is oxygen valve and there is generally acetylene valve, which is look like this. This is actually practical welding torch. Now here you see this is called handle. Generally in this oxygen valve and what it's called fuel valve, this hose is connected. Hose is generally connected like this. So by contour here, generally by opening this oxygen valve, acetylene valve, this gas is flowing through this handle. Inside this handle there is two different pipe, which is one is connected to the oxygen valve, another is connected to acetylene valve, or we can say fuel valve. So after that, generally these two gases mixing occurs in this region. Here you see in this region mixing of these two gases, this is called mix chamber. Here generally these two different pipe combinedly deposit or we can say supply the gases together, and here generally mixing of gases is occur. After that, generally this nozzle generally used for generation of arc. How this arc is generating? This arc is generated by a spark lighter. Generally here once the gas is coming out from there, if we generally spark a light here, then what happens? This gas flame is generated. So this is the welding torch, the detail welding torch. Here generally this nozzle head, whatever the head of the nozzle is showing, there can be different types of nozzle. Here you see different size of nozzle. Depending on our requirement, there we can use different size of nozzle. Generally here different size of nozzle means this nozzle diameter, tip diameter generally depending upon its size, it's varying. So, as per our requirement, actually we can use different size of nozzle, and this is called gas regulator. How the gas regulator is look like? This gas regulator, one terminal is connected to cylinder, this another terminal generally connected to hose pipe, and this is connected to what it is called hose pipe. It has, I have already told you, it has generally two regulator. One regulator represent what is the gas pressure is inside the cylinder, and another indicators or another regulator represent the working pressure. That means what is the pressure supplying to the torch tip, that is represent generally another indicator. This is the detailed view of a regulator. Now, we will discuss about first of all we will discuss what are the different gases generally, that means fuel gases generally used. So, first of all we will discuss about what are the different gases used in oxy-fuel welding. So, here I have already told you the main principal gas or we can say the principal gas used in oxy-fuel welding are oxygen and acetylene. Generally this is the principal gases generally which are used in oxy-fuel welding. It has wide application also. Now, here this oxygen generally used to support the combustion, and this fuel gas or you can say acetylene gas generally supply both heat intensity and the atmosphere for needed the welding operation actually. So, what is the function of oxygen gas? Oxygen gas generally support the combustion, because without oxygen generally combustion is very difficult. So, that is why generally for supporting the combustion oxygen gas is required. So, main function is supporting the combustion is oxygen, and the second fuel gas function is it supply the heat intensity for doing the welding operation as well as the atmosphere needed to do the welding. Atmosphere needed to do welding means that means if these types of fuel gas will not be there, then what happens, there can be different types of defect, that means oxidation, carburization, different actually these types of atmosphere, that means whatever the atmosphere needed for doing welding operation, that also supplied by these fuel gases. Now, another gases generally used, as I have already told you in first slide itself, that gas can be hydrogen gas, that is fuel gas. These are all fuel gas actually. That can be natural gas like methane, that is CH4, generally methane, its chemical formula is CH4. This can be propane, it is generally C3H8. It can be proprietary gas also or LPG gas. Proprietary gas means generally LPG gas, liquid petroleum gas actually, are also used to limited extent in oxy-fuel gas welding. Its application have very limited, because what happens, this generally can supply cannot supply proper temperature or we can say proper atmosphere required for doing different welding. That is why what happens, it has limited application, especially some low melting point temperature, what is called low melting point temperature metals or and their alloy, and for doing welding operation, and sometimes it is also used for brazing operation also. Now, one by one I will discuss in details about these gases, how what is the function of these gases, what should be the type of this gas, what should be the safety precaution of this gas, that means, and what should be the cylinder capacity and all the things. This idea we should know, because we are discussing about this welding technology. So, about everything of this welding technology we should know. So, first of all we will discuss about oxygen gas. Generally oxygen gas, whatever oxygen gas generally used for oxy-fuel welding techniques, it should have a purity, that means here oxygen should be 99.5% and it should be purity of 99%, 99.5% and higher, because one thing you should keep it in mind, a small percentage of contaminants have a noticeable effect on combustion efficiency actually. If there is a small amount of contaminant is there inside the oxygen gas, then what happens, its combustion efficiency is drastically affected. That means you can say reduce a lot, the combustion efficiency reduced a lot. And another things you should keep it in mind, this oxygen you can store in cylinder either in gaseous form as well as in liquid form. If the oxygen requirement is less, then generally you can store the oxygen gas in oxygen in gas form inside the cylinder. Here one thing you should keep it in mind, this oxygen gas cylinder pressure should not more than 180 megapascal, that means 180 MPa. This you should keep it in mind. Now cylinder volume capacity or cylinder capacity is 6.91 meter cube. Whatever the capacity used, it can contain a volume of oxygen that is 6.91 meter cube. The most frequently used cylinder has a capacity of that much meter cube, that means 6.9. Now here one thing you should keep it in mind, when this oxygen usage increase, that means oxygen consumption increase, then what happens, it is better to use this oxygen in liquid form. Because what happens, once you store this in liquid form, it may be more economical to obtain. Once you store this oxygen in liquid form, then it will be more economical, because on the consumption of oxygen will be more, then it is better to store it in a liquid form, then it will be more economical. Now we will discuss about acetylene gas. Then generally this acetylene gas is chemical formula is generally C2H2. It is generally hydrocarbon. This gas is very unstable, always keep it in mind. This gas is very unstable when it is used under the pressure of 203 kPa or above. That means if the acetylene gas is used above a pressure of 203, that means 203 kilopascal, and it is above, then what happens, a slight shock can cause it to explode. That is why this explode can happen on its pressure is above or equal to 203 kPa. This explode can happen without the absence of oxygen also, oxygen or air also. So that is why you should keep it in mind from safety point of view. We should keep the cylinder pressure below this. Generally safety rule for the use of acetylene and handling of the acetylene equipment are extremely important. This you should keep it in mind. This safety rule is extremely important for acetylene gas. This gas, always keep it in mind, this gas should not be used at a pressure greater than 105 kPa, that means 105 kilopascal. This is the main safety precaution for acetylene gas, because what happens, if the gas pressure is in, what I have already told you, there is a chances of explode of the gas. And another things you should keep it in mind, acetylene cylinder must not be subjected to sudden shock, and it should be stored well away from any source of heat and sparks. This you keep it in mind, because acetylene gas is unstable types of gas. It is generally very unstable, or it can be a very dangerous gas actually. Now we will discuss about this methane, propane and proprietary gas. This methane, generally propane and proprietary gases may be used with oxygen to weld some. Generally this has the application for some low melting temperature metal. It is used for very low melting temperature metal, especially like aluminum, manganese, then lead, like bronze. These types of metal generally can be welded by these types of gases. Usually this gas mixture cannot be used to welding of steel, because burnt to a temperature high enough for doing the welding of steel, then its flame characteristics become excessively oxidizing. That means when the temperature goes beyond some certain limit to do the welding of steel, then generally this flame characteristic become highly oxidizing. Especially oxidizing flame is not suitable for doing what is called steel welding. That is why this flame cannot be applied to do steel welding. And what happens, if we go for making this oxy-fuel characteristic to reduce characteristic, then its temperature is not sufficient to do the welding of steel. That means for carburizing flame, whatever the things we are getting by using this fuel gas, that carburizing flame generally is not sufficient to do the welding of steel pipe, because its temperature is not that much high. For that reason, these gases have limited application, especially to heating, brazing and some extent of braze welding. Now generally we will discuss about hydrogen gas. Hydrogen is also another fuel gas which is generally used mainly for welding, again no low melting temperature metal, especially aluminum, magnesium and lead. Generally this hydrogen gas is used. It cannot be used to weld common thickness of steel sheet, because it results in a flame temperature that is too low, which is not suitable to produce good fusion. That is why it is not used common thickness of sheet plate, but this flame temperature we can use to join thin sheet of metal, because this generally its combustion intensity, this fuel combustion intensity is within a range of 60% of acetylene or oxyacetylene combustion intensity. So, this lower intensity flame which is good for lower thickness of steel plate. That is why for low thickness steel plate this type of flame is advantageous. It is generally used for brazing and some extent of braze welding actually. This gas is available in compressed gas cylinder of various size. Generally this hydrogen gas cylinder color is red in nature. Red types of color generally used. To see the red color of the cylinder, we can say what is the gas available inside this cylinder. So, it has different size also. This gas cylinder have different size also. Now, we will discuss first of all combustion of oxyacetylene gas, then we will discuss about combustion of other fuel gases. So, first of all we will discuss about combustion of oxyacetylene gases. Here as the oxyacetylene mixture burn from the tip of the welding torch, it displays several clearly recognized zone of combustion. So, when the flame come out from oxyacetylene torch, that flame contains several clearly recognized zone of combustion. The overall chemical equation for complete combustion of the oxyacetylene gas is represented in equation 1. Here what you can see here 2 volume of acetylene gas with 5 volume of what it is called oxygen gas. Complete combustion required 2 volume of acetylene gas and 5 volume of, or you can say, oxygen gas, and after that it produce this H2O and CO2 gas, carbon dioxide gas. This complete combustion of oxyacetylene gas taken place in 2 steps, or you can say in 2 stages. So, in first stage what happens, in first stage the oxygen used for combustion is supplied from the oxygen cylinder. Whatever the oxygen required for combustion, that is generally supplied from the oxygen cylinder. This reaction what happens, due to this generally the reaction can be seen as a small inner cone of the flame. Here generally the highest temperature is at the point of this cone. So, this is the first stage of oxyacetylene combustion. Here this acetylene gas as well as this oxygen gas which is supplied from directly from the cylinder. So, here due to this here carbon monoxide and hydrogen gas is used. This in the second stage generally the output of this first stage used in second stage. Here the rest of the oxygen, whatever the rest of the oxygen are there here, this oxygen generally coming from the surrounding atmosphere. So, here in equation 5 we have seen that there is 5 molecules of oxygen are there and 2 molecules of acetylene are there in this reaction equation. So, among these 5 molecules of oxygen, 2 molecules of oxygen you can say, or 2 proportion of volume is coming from cylinder, rest 3 proportion is coming from the atmosphere. That is why here one thing you should keep it in mind, that means here for complete combustion of oxyacetylene flame, here 3/5 of the total volume of oxygen coming from atmosphere. That is why here one thing keep it in mind, because of the need for supplementary oxygen from the atmosphere, the oxygen acetylene flame cannot be used inside the tube structure subjected to oxygen depletion. This you keep it in mind. For oxyacetylene welding generally you should use there where there is a less chance of oxygen depletion are there. There is sufficient oxygen are there, because for doing this welding operation generally 3/5 of the total volume of oxygen coming from atmosphere it is required. Now we will discuss about due to this oxyacetylene combustion what are the different types of flame generated, categories of different flame generated, as well as we will discuss here how the oxyacetylene flame adjustment is done, that I will discuss. Because what happens by adjustment of the oxyacetylene ratio, oxygen to acetylene ratio, generally here you can control the characteristics of flame. That means what happens, as per our requirement, generally expert welder can generate the required flame by controlling the ratio of what it is called oxygen and acetylene ratio. How this adjustment is done, that I will discuss, and I will discuss what are the different types of flame generated. What are the different types of flame generally are there in oxyacetylene welding technique. So, first of all, I will discuss about oxyacetylene flame adjustment. This is the sequence for setting up a positive pressure welding outfit actually. Here first of all, check all the part of the apparatus, that means making sure there are free of dirt, oil or grease and in proper working condition. First of all, we have to see, that means all the apparatus should be neat and clean. There should not be dirt, oil, grease or grease types of things over the apparatus. Then then generally open the cylinder valve slowly and carefully. This we should keep it in mind. And when we will go for opening the cylinder valve, then at that time the operator should never stand in front of the regulator. Then that means operator should stand beyond the regulator. What happens when opening the cylinder valve? That means in front of regulator, operator should not stand. Because what happens during opening of this valve, there is a chance of removing that regulator from the cylinder. So, that can create accident. That is why operator should stand beyond the regulator. So, first of all, wash out the oxygen line valve while acetylene line is closed and acetylene line when oxygen line is closed. That we should keep in. That means one by one we should clean that hose of the or pipe of the oxygen gas supply and another hose of the fuel gas supply. This we should clean one by one. So, that means when we clean the oxygen hose, that time acetylene valve will be closed. When we clean the acetylene or fuel hose, that time oxygen will be closed. Then set the oxygen and fuel gas regulator to the recommended working pressure with appropriate torch valve open. So, by appropriate torch valve open, here one thing you should keep it in mind, before starting the torch itself or before starting the flame itself, we should control the or we should generate the working pressure. That means what should be the outlet pressure of the gas from the cylinder. Then here one thing to keep it in mind, on the working pressure setup completed, then before welding, first of all we have to open the acetylene valve, acetylene inlet valve, and by acetylene inlet valve, once we open the acetylene gases, then light the welding torch using a spark lighter. So, in acetylene gas only we have to light the gases by a spark lighter. So, at that time generally when the flame started, at that time there is no oxygen supply from the oxygen gas. So, when that flame started, then generally we gradually in the second, that means in second stage, then open the oxygen inlet valve and adjust the flame using both the inlet valves. So, first flame is started without supply of oxygen from cylinder by only fuel gases. Then generally what happens, then this oxygen valve gradually open. By these we can control the characteristics of the flame. That means by changing the proportion of oxygen supply to this flame, we can change the characteristics of flame. Here this different welding atmosphere and flame temperature can be produced by varying the relative amount of oxygen and fuel gas in gas flowing to the tip of the torch. This you should keep it in mind. So, by controlling this ratio of this oxygen and acetylene gas, we can generate different types of temperature as well as different types of atmosphere of welding. Now, we will go for categories of oxyacetylene flame. The type of flame produced depends on what I have already discussed, that means depends upon the ratio of oxygen to acetylene in the gas mixture, which generally leaves from the torch tip. That means whatever the gas mixture is coming out from the torch tip, whatever the ratio of this oxygen and fuel gases or acetylene gases, depending upon that ratio generally this flame whatever generating, that flame can be categorized into three main categories. So, these three main categories, what is these three main categories? One is called carburizing flame. Here excess acetylene are there, that is why it is also called excess acetylene flame. Second one is called neutral flame. Here the ratio of oxygen to acetylene is 1:1. Then third one is called oxidizing flame. Here generally how it look like. This first one is called acetylene flame. Generally in acetylene flame, when the arc is initially started, here it's look like this. Now once we increase the means once we supply the oxygen with this acetylene gas, then this reduced to reduced flame. Reduced flame means there is a combination of oxygen and acetylene is there, but the proportion of oxygen is lesser than acetylene gas. So it look like generally it has a outer envelope and there is a what happened, there is a acetylene feather with a inner cone, with a inner cone also there. There is a acetylene feather and a inner cone is there. Then if we increase further the oxygen gas, then this acetylene feather vanished and this inner cone remains. So this is happen in case of neutral flame, where the proportion of oxygen and acetylene gas is 1:1. And at the if we further increase the oxygen gas with this acetylene gas, then this inner cone generally further shortened. So this further shortened and it become more sharp, and this outer envelope also shortened. Then what happens? It's generally converted to oxidizing flame. In this oxidizing flame, one thing you should keep it in mind, in this oxidizing flame the proportion of oxygen is more than the acetylene gas. Its ratio within 1.52:1, like this types of ratio are there, oxygen to acetylene ratio. So here one thing you keep it in mind, here temperature increases with increase of oxygen concentration over this flame. That means acetylene flame has less temperature then reducing flame, the higher temperature than acetylene flame, and in this way this temperature increasing once the proportion of oxygen increase with the acetylene gas. That is why among these oxidizing flame have higher temperature and among these acetylene gas has lower temperature. I will discuss one by one in details about these different types of flame. So first of all I will discuss about acetylene flame. Generally then the acetylene flame, that means in this then I will discuss about neutral flame, then I will discuss about the carburizing flame. So the acetylene flame, when acetylene alone is burned in air, that means when the arc is started, it produces a flame that varies in color from yellow near the torch tip to orange red at the outer extremity. This is here you can see at the bottom of this slide, this is actual acetylene flame, where you can see here orange red types of flame is there at the extremity, and near the torch tip color is yellowish type. Now with this acetylene flame, once we supply oxygen gas, then depending upon the presence of excess of acetylene, that means in oxyacetylene flame, this acetylene flame, oxyacetylene flame can be categorized. That means where the excess of acetylene is there, depending upon the excess of acetylene, this flame can be two different categories. What is these two different categories? One category is called carburizing flame, where and another category is called reducing flame. Here one thing you keep it in mind, in case of carburizing flame, generally it has a capability to carburizing operation. That means carburizing is a hardening operation. So what happens here, the acetylene proportion is higher than the reducing flame, but here proportion of acetylene for both the flame, proportion of acetylene is more than the oxygen. That way, but here the proportion of acetylene gas is more in case of carburizing flame than reducing flame. Reducing flame is also a what is called acetylene types of flame. Here more acetylene are there. Now I will discuss one by one in about this. That means on carburizing flame, and another one is reducing flame. Carburizing flame generally, as the oxygen valve in the torch is progressively opened and the ratio of oxygen to acetylene increase, the flame become generally bright. Then the bright portion contact toward the welding tip. Here you see this is carburizing flame. So here this bright portion generally gradually contract towards the welding tip and forming a distinct bright zone. Here you see forming a distinct bright zone within a blue outer envelope. Here within a blue outer envelope there is create a bright inner cone. You see bright inner zone. Here you see from this is different color and actual shape of carburizing flame. This is a carburizing flame because it has a large excess of acetylene are there. It is sometimes described as soft flame, because these types of the carburizing flame has very little force. Its force is though higher than acetylene flame, but then also its force is very little. That's why these types of flame are relatively used in low temperature alloy. So, it has a relatively low temperature, and that is why it is used in silver brazing and soldering purpose, as well as it is used also for welding of lead. As it is a carburizing flame, that is why it has a wide application for carburizing purpose. Carburizing is a generally process of surface hardening process. So, for this characteristic, carburizing characteristics, or you can say presence of acetylene gas is more, that means presence of hydrocarbon is more. So, it produce carburizing types of flame. Why it is called carburizing flame? Because this flame we can use for carburizing purpose, that means surface hardening purpose, but this reducing flame cannot be used for carburizing or surface hardening purpose, because in reducing flame generally the proportion of acetylene is less than carburizing flame. It cannot produce carburizing effect. Then once I will discuss about this reduced flame, then it will be very clear to you. So, generally reducing flame means here the flame temperature is around 3040 degrees centigrade. This flame has a slightly excess acetylene or reduced flame, but less than the carburizing flame. Though slight excess acetylene is there, but generally its acetylene content is less than what it is called carburizing flame. As some oxygen is introduced, the bright zone of the flame contract further and is seen to consist of two parts. So, as more oxygen is introduced, the bright zone of the flame contract further and is seen to consist of two parts. What are these two parts? Two parts are, one is called bright inner cone. Here you see bright inner cone, this black here it is showing, but it is very bright color, bright inner cone, and a pale green feather, or you can say this pale green feather is called actually acetylene feather. The feather is caused by a slight excess of acetylene. This feather disappears as the oxygen to acetylene ratio approaches to 1:1, because once the acetylene oxygen gas further increases to this mixture, feather gradually decreases and it vanishes once this ratio become 1:1. That means oxygen to acetylene ratio become 1:1. That is why then for welding steel, the length of the feather, here one thing you should keep it in mind, to see this feather size we can generate the required atomosphere for doing steel welding. How? Generally for welding steel, the length of the feather should be about 1/8 to 1/4, but never exceed more than 1/2 the length of the inner cone. That is why here it is showing, if the inner cone size is x, then this acetylene feather size should not more than 1/2 of x, because once it more than 1/2 of x, then this will not be suitable for doing steel welding. That you should get. This should be as much as lesser than what it is called, lesser than this. If it is lesser than, that means if it is more than x but lesser than 1/2 x, then what happens, it is good for doing steel welding. That generally expert welder can visualize and can control that thing during welding operation. Here it should not be called as a carburizing flame, because it does not, what I have already told you, it does not carburize the metal. That means that surface hardening it cannot do, it cannot perform, but it does ensure the absence of oxidizing condition also. But here oxidizing condition also is not there. It is generally apply in low alloy steel, high carbon steel and non-ferrous material, especially that material which does not tends to absorb carbon. So, in that material which generally does not tends to absorb carbon, they are generally this reducing flame widely used. Apart from that thing, it is also used low alloy steel and high carbon steel also. Now, neutral flame. So, neutral flame further increase with this reduced flame. If we further increase the what it is called oxygen content, then what happens, it approaches to 1:1. So, once the ratio of oxygen and acetylene is become 1:1, then this flame is called neutral flame. This neutral flame have a temperature is about 3260 degrees centigrade. So, this neutral flame, what I have shown in second equation during explanation of combustion of oxyacetylene gas, there we have shown that that oxygen and acetylene in second equation, that means equal amount 2 molecules of oxygen and 2 molecules of generally acetylene gas combine and it's produce carbon monoxide and H2O. That equation represent the during this combustion period where equal amount of oxygen and acetylene are there. During that time generally this neutral gas is formed. This neutral gas neither excess acetylene nor excess oxygen is present. So, it has a maximum temperature which is around 3260 degrees centigrade, which is generally observed in inner cone of the acetylene gas. In case of neutral gas, this acetylene feather vanish and here developed a bright inner cone. Here how the temperature varies in a neutral flame from tip of the torch tip to flame tip, that I am showing here, how it is varying. This is relative temperature distribution in flame. In inner cone, this temperature is around more than 3000 degrees centigrade, which is maximum can be around 3 to 6 degrees, and generally it's further gradually decrease away from this inner cone. How it is decreasing, that it is showing. From this you can feel how the temperature is varying in a neutral flame. This flame is called neutral flame, and the gas mixture is often here it is described as oxygen to what I have already told you, oxygen to acetylene ratio of 1 to 1. So, when the presence of carbon must be strictly avoided, you should keep it in mind, and when oxidizing condition also unacceptable. So, both generally carbon must be strictly avoidable and oxidizing condition is also avoidable. So, for this cases generally, especially this in case of stainless steel, these two conditions should be strictly avoidable. That means there should not be carbonizing condition or there should not be oxidizing condition. So, for doing this stainless steel, this neutral flame is generally essential for good result. So, generally for doing stainless steel, we should go for neutral flame. So, this is the basic feature and application of this neutral flame. It has a light, generally this is a neutral flame, practical neutral flame. Here one thing you can say, it has blue inner cone, this is a blue inner cone with a darker blue outer envelope. You see, it is a darker blue outer envelope. A neutral flame is named so because it affects no chemical changes in the molten metal and therefore will not oxide or carbonize the metal. So, why it is called neutral flame? Because no chemical changes in the molten metal is occur by using this flame. Neutral flame have wide application. It generally used in mild steel, stainless steel, cast iron, aluminum, copper. So, it has lot of application. We can use this neutral flame in different material. Now, the last categories of oxyacetylene flame, that is called oxidizing flame. Here this is oxidizing flame. Here what I have told you, if we increase the oxygen percentage or oxygen proportion, its flame temperature gradually increase. Here the maximum temperature is more than the neutral flame, that is 3315 degrees centigrade. It is produced when more than 1 volume of oxygen is mixed with 1 volume of acetylene. So, here proportion of oxygen is more than the proportion of acetylene gas. Here the basic feature of this gas, it has a small white cone. Due to this further increase of oxygen gas, this inner cone generally further shortened. So, that is why it has a small white cone which is much shorter, much bluer in color and more pointed than a neutral flame. So, whatever the bright cone we have seen, whatever the small inner cone we have seen in case of neutral gas, in case of oxidizing flame, this inner cone size is shorter than that. The flame should be sufficiently rich in oxygen to ensure that a film of oxide slag form over the weld to provide shielding for the weld pool. This flame also sometimes good for some types of material, because this oxide layer forming over the surface of the weld metal sometimes helpful for shielding purpose. That is why this is also applicable for some material. So, here the oxygen to acetylene ratio is what I have already told you, is about 1.5:1. And oxidizing flames should never be used in welding steel, that you keep it in mind. Generally what happens, once we use oxidizing flame for doing steel, so there will be defective weld. So, generally it is used only in welding copper, then certain copper based alloy and zinc based. So, it has limited application, then but for a copper and certain copper based alloy, this oxidizing flame is giving good characteristics weld. Now, the flux requirement, sometimes flux also required in case of oxy-fuel welding, except for lead, zinc and some precious metal. Oxy-fuel welding of non-ferrous metal, cast iron and stainless steel require a flux. That except for this lead, zinc and some precious metal, oxy-fuel welding requires flux. Once that like it can be non-ferrous metal, cast iron, stainless steel, flux is required. In welding carbon steel, the gas flame shielded the weld adequately, that is why for doing carbon steel flux is not required, but flux is required for cast iron, stainless. Flux means what happens, which is required to protect the molten pool from atmosphere. Some sort of material are there, that I will discuss subsequently. So, that is used to protect the molten pool from atmosphere contamination. So, that flux generally sometimes require in case of oxyacetylene welding, sometimes it is not required. Where it is required, that I have already told. Now, in next lecture I will discuss combustion of other gases. What are the different combustion of other gases? Then I will discuss what are the different categories of oxy-fuel welding techniques, and I will also discuss what is the application, what is the advantage, disadvantage, what should be the safety precaution of this welding techniques in detail.